So today we will be learning how to calculate for Gibbs free energy. Calculate delta G for the reaction of benzene with hydrogen gas to give cyclohexane using the following data. Delta G of formation for benzene is 124.5 kilojoules per mole, and delta G of formation for cyclohexane equals 217.3 kilojoules per mole. And you will also, by the end of this video, know whether or not if this reaction is spontaneous. So what do we need to know in order to calculate this problem? Well, first of all, delta G is the standard free energy change. And under standard conditions, this means that you're working with 298 Kelvin or 25 degrees Celsius, 1 molar for your concentration, and 1 atm for your pressure. We will also need to know what the delta G of formation is. So delta G of formation is the change of standard free energy for the formation from elements, and standard conditions apply here too. We also need to know what is benzene and cyclohexane and hydrogen gas, which is given by these formulas. So benzene is C6H6, cyclohexane is C6H12, and hydrogen gas is H2 gas. And we'll need this later on in order to actually write out our reaction. So because we are working with standard conditions, we are able to calculate the standard free energy of the standard free energies of formation which we were given in our original problem. And we can do this by using this handy formula. So delta G at standard conditions equals the sum of the delta G of formation of your products subtracted by the delta G of formation, the sum of the delta G of formation of your reactants. So again, I was talking about writing your reaction. You need to actually write out your reaction that was given in Word, and you need to make sure you balance it, which is why I have 3 hydrogen gases here. So you were given these 2 delta G of formations, and we know that hydrogen gas has a delta G of formation of 0 because any free element in its standard state is 0. So by using that handy formula that I showed earlier, we are able to calculate Gibbs free energy. So you take your kilojoules per mole of your product, subtracted that by the sum of the kilojoules per mole of your reactants, and you get a positive 92.8 kilojoules per mole. So I also promised you that we would be able to see if this reaction was spontaneous or not. So it is important to know that delta G, if it is positive, it is non-spontaneous, and if it is negative, it is spontaneous. So in our case, we had a positive 92.8 kilojoules per mole, which means this is a non-spontaneous reaction, which also means that it requires external energy in order for this reaction to occur. Thank you for watching my video.